So here we have 8s and we have 12s. And what we're doing is we're going to add these 3 8s to these 2 12s. So we have 3 8s plus 2 12s. And before we add 2 12s, we wonder, could we simplify that in any way? Well, actually, 2 and 12 are both even numbers. So I probably wouldn't add 2 12s. I'd probably divide top and bottom here by 2 to add 1/6 instead, because 2 12s is exactly the same as 1/6. And it will be easier to find a lowest common denominator if I'm actually smallest number as possible in the bottom. Now when I try and put these 8s and these 12s together, I can't actually see exactly what fraction it is. I can look at it and say, it looks slightly more than a half, because a half would go down here. But what fraction is that going to be? And a lot of you feel tempted to change it into decimals. When you change it into decimals with a sixth, we're going to get a recurring number, 0.16666. So we're not going to get an exact answer. So if they give you a sum to do in fractions, do the sum in fractions. Okay, now we have to find out what's the lowest number that both 6 and 8 will divide into. We can start thinking of our 8 times table. 8, 16, 24. 24 also is divisible by 6. So our lowest common number that both of them will divide into will be 24. That means I've got to change 6 into 24. And I've got to change 8 into 24 as well. Because if I can change these fractions so that I get 24 on the bottom, I can suddenly add these fractions. Do you understand why I've changed it to 24 on the bottom? What do I multiply 8 by to get 24? 8, 16, 24, 3 times. If I multiply this 8 by 3, I have to multiply the top fraction by 3 as well. I'm allowed to do whatever I want to fractions as long as I do the same thing to the top as I do to the bottom. And this is called an equivalent fraction. So 3 3s are 9. 8 3s are 24, giving me the bottom fraction. 3 3s are 9. So 3 8s is equivalent to the fraction 9 24ths. What do I multiply 6 then to get 24? Well, I'd multiply it by 4. If I multiply the 6 by 4, what do I do to the top number? Also multiply it by 4. So I now have 1 times 4 is 4, and 6 times 4 is 24. Now I have the same denominator, so now I can actually add these fractions. 24 is the denominator. We make sure we never add this. We're counting in how many pieces we've converted these 8s into. So if we think about each of these pieces of 8 here, what we've done is, here's our piece of 8. We've just converted it into, instead of it being 8s, we've split it into pieces of 24 instead. So 9 plus 4 is 13. 13, what were we counting in? We were counting in 24ths. So we get the answer of the fraction 13 24ths, which is very close to what we were expecting. We could see it was slightly bigger than 12 24ths, but we couldn't actually see what fraction it was. If we'd done a subtraction sign here instead, if we'd taken 1/8 and we were going to actually take away 2 12ths instead, it doesn't work on top of one another. But if we were going to take away 2 12ths from 1/8 and wonder how much we would have left, we'd do the same thing. We'd change 3 8s to 9 24ths, and we'd subtract 4 24ths to give us the answer of 9 minus 4 is 5. So this piece of cake that's left is equivalent to the fraction 5 24ths. And we can't simplify that anymore. So we can leave it in that form. So adding and subtracting fractions is easy as long as you make sure that you take the same denominator. That's the key to adding and subtracting fractions. If the denominator isn't the same, don't do anything with it. Make it the same.